In this video, I am going to show you how to solve exponential equations using logs. In one of my videos, I went over solving exponential equations using a common base. So we're going to review an example of how to solve exponential equation using a common base. Okay, so here's the example. Let's say I have 9 to the a plus 2 is 27 to the 4a minus 2. Okay, so this is an exponential equation, and I would like to solve this for a. What we have to do here is we have to rewrite both sides of the equal sign using a common base. Okay, so let's think about the number 9 and the number 27. Okay, can I rewrite those two numbers using the same base? Well, I can rewrite both of these numbers using base 3. Okay, so 9 can be 3 squared, because 3 squared is the same as 9. That's to the a plus 2. And then 27, I can rewrite that as 3 to the third power, and then to the 4a minus 2. And then here I have 3 to the 2a plus 4. And then over here I have 3 to the 12a minus 6. And then I can cross out the bases and then set the exponent equals to each other. So I have 2a plus 4 is 12a minus 6. Okay, solve for a. I need to get a on the same size of the equal sign. So I would have to minus 12a here, and then minus 12a here. Okay, so here I have negative 10a plus 4 is, these are gone, bring down the negative 6. And then take away 4, take away 4. So I have negative 10a. Okay, these are gone. Is negative 10. And then to get the a, I would have to divide by negative 10. So divide this by negative 10. Divide this by negative 10. So a is 1. So we did these types of problems before where you solve an exponential equation and where you're able to use a common base. So what if a common base is not possible? Okay, so that's what we're going to get into in this lesson, where we're going to solve an exponential equation that common base is not possible. So we would have to use logs to solve for the unknown. Okay, so let's take a look at this example right here. Okay, so here I have 10 times 5 to the 3k minus 3 is 40. Okay, and then I would like to solve for k here. So the first thing I have to do is to isolate the exponential expression. Okay, so I need to get this here all by itself. So I've got to isolate that expression. So that means I got to get rid of the multiply by 10. So how do I do that? Or I would have to divide by 10. So if I divide the left hand side of the equal sign by 10, I got to do the same thing to the right hand side of the equal sign. Okay, so 10 over 10 cancels out. So I'm left with 5 to the 3k minus 3 is 4. Okay, so now I would have to rewrite the 5 and the 4 using a common base, but it looks like that I'm not going to be able to do that, okay, with the 5 and the 4. Okay, so step 2 is to take the log of both sides. So because I cannot rewrite using a common base, I would have to take the log of both sides. So here I go log 5 to the 3k minus 3 is log 4. Step 3 is to expand the log. So I would have to expand the log using the properties of logs. Okay, using the power property here, I'm able to bring down the 3k minus 3. So it's going to look like this now. So 3k minus 3, okay, that whole thing times log 5 is log 4. Okay, then to solve for k, I would have to get rid of log 5. So I can do that by divide with log 5. So here divide by log 5. Here divide by log 5. So these are gone. So you're left with 3k minus 3 is log 4 over log 5. Alright, solve for k's. But first we can evaluate this using a calculator. Okay, so with the scientific calculator, all you have to do is punch in log 4, divide by log 5. And if you do that, it's going to give you 0.8614. And solve for k, I would have to add 3. Add 3. So here I have 3k plus 3 minus 3 is gone, equals to 3.8614 when you add those two numbers. And then divide by 3. Divide this by 3. So k is going to come out to 1.2871. Okay, so this is what k is. Okay, so let's take a look at another one. So here I have 8 times 11 to the 7k. Take away 3 is 213. And we're solving for k here. Okay, let's take a look at the procedure. Okay, so first thing I have to do is isolate the exponential expression. So I need to get this expression right here all by itself. This is the exponential expression. So I have to get rid of the minus 3 and then multiply with 8. Okay, so to get rid of the minus 3, I would have to add 3 and then add 3. Then I have 8 times 11 to the 7k, and then these are gone, is 216. Now I would have to get rid of the multiply by 8, and that is to divide by 8. So divide by 8. 8 over 8 is 1. And then you're left with 11 to the 7k is, well, 8 goes into 216 is 27. Okay, so that is step number 1. Okay, is to isolate the exponential expression. And then step 2 is to take the log of both sides. Okay, so we're going to take log both sides. And this is log base 10. So log base 10 of 11 to the 7k. And then log 27. Okay, so now we're going to have to expand the log using the power property. Okay, we can bring down the 7k to the front. So I have 7k log 11 is log 27. To get the k by itself, I would have to divide this whole thing by 7 or log 11 because I need the k, and then divide this 7 log 11. Okay, so I can punch it into the calculator. So k is going to be, this is how you want to punch into the calculator. So you got log 27. Okay, you're gonna put that in parentheses. Divide by 7 log 11. Okay, so this is going to give you 0.1964. Okay, so this is what k is. Okay, so let's take a look at another one. So for this one, I have 3 times 8 to the 3 minus 7n plus 10 is 94. Okay, solving for n. So first thing I have to do is isolate this expression, the exponential expression. So I have to get rid of the plus 10 and multiply with 3. So to get rid of the plus 10, I minus 10 minus 10. So then I have 3 times 8 to the 3 minus 7n. These are gone. Is 84. And then divide by 3. And then divide this by 3. So these are gone. So I have 8 to the 3 take away 7n is 84 over 3 is 28. Okay, so now that I cannot rewrite the 8 and the 28 using the same base, I would have to take the log of both sides. So I gotta go log base 10 of 8 to the 3 take away 7n is log base 10 of 28. And then expand this using the power property. I'm going to be able to bring down the exponent to the front here. So I end up having 3 take away 7n. Okay, and that whole thing times log 8 is log 28. Okay, solve for n is to try to get the n all by itself. So I would have to first divide by log 8 to get rid of the log 8. Divide this by log 8. So I have 3 take away 7n is, okay, these are gone. So log 28 over log 8. Okay, input that into the calculator. You get 1.6025. And then solve for n here. I would have to minus 3, minus 3. Okay, so these add up to 0. Bring down the negative 7n. And then on the right hand side, I end up getting negative 1.3975. And then divide by negative 7. Divide this by negative 7. So n is 0.1996. Okay, so this is what n is. Okay, so let's take a look at one more. So for this one, I have 8 times 11 to the 3p take away 9 plus 10 is 194. And I'm solving for p here. Okay, so first thing I need to do is to isolate the exponential expression. So I gotta isolate this expression. So get rid of the plus 10. So I need to minus 10, minus 10. Okay, so I have 8 times 11 to the 3p minus 9. Okay, these are gone. Is 184. And then divide by 8. Divide by 8 to isolate the exponential expression. So these are gone. So you're left with 11 to the 3p minus 9. And then on the right hand side you have 23. 8 goes into 184 23 times. Okay, so now we're going to take the log of both sides, since we're not able to rewrite 11 and 23 using the same base. So we go log 11 to the 3p minus 9 is log 23. Okay, so expand here. We're going to be able to bring down the exponent to the front of this log. So you have 3p minus 9. 3p minus 9 times log 11 is log 23. Okay, so here divide by log 11 and then divide this by log 11. So I have 3p minus 9 is, these are gone, it turns into a 1. So in here I have log 23 divided by log 11, punch it into the calculator. I'm going to get 1.3076. And then to get the p all by itself, I would have to add 9 and then divide by 3. So here I would have to add 9. So I got 3p is 10.3076, and then divide by 3, divide this by 3. Okay, so p is, it's going to be 3.4359. Okay, so this is what p is.